Are we drunk, folks? Yeah, we're gonna have a good time this Friday and Saturday. You wanna meet me at the bar? I mean, I think that's probably what this is gonna be like when we do blood alcohol concentration. You know, very often I'll watch the cop shows, and I love them because they're pulling people over on the side of the road, and they are making a complete fool of themselves, and everything is on camera. And I'm always thinking, like, how on earth can you be that bad in order to do the kind of stuff that you're doing on video, permanently recorded, so that way 20 and 30 years from now you're going to look back on this and you're going to watch that old YouTube or that old cop show with that video that shows how crazy you were acting, and that was all because of blood alcohol concentration. So folks, make a very wise decision and drink responsibly. Thank you for the state of North Carolina for supporting this video. Well, no, they're really not, but I hope they do, and I hope that they watch this video, because I think some of the crime labs need to figure out how to do the blood alcohol concentration the right way, because if I'm not mistaken, I think that I have read many articles about crime labs not really following the rules. Now, I'm not saying Wilmington, but crime labs across the United States, they're always scrutinized and they're always docked because they are not following certain parameters that we would like for them to follow. So in this example, or in this video, we're going to talk about blood alcohol concentration, also known as BAC. And with this one, you are my lab partner. Oh my God, yay, you're my lab partner. Well, what this means is that I'm doing most of your work for you. Yay! All right, you love that. I know you do. But with that said, I might be doing the work and you might be my lab partner, but the questions are going to be very detailed in this lab experiment. So when you go online and you open up the assignment that goes along with this video, it will not be timed. It's going to give you time to go through, kind of watch the video, maybe pause it, answer some questions, go back to the video, watch it, pause it, go back, answer some questions. It by no means is it timed at all, but I'm going to give you a little insight of what these types of questions are going to ask for. So you're going to be my lab partner here, and the reason that we do this is that there is no way, there's no way that you can actually come into the lab and do some of the sample prep, or us to send you home a kit for you to make at home and then just bring back to us like in some of our other labs. The reason I say this is because these samples have to be prepped on the same day, and your schedules are probably not going to line up the proper way, and they have to be ran on the same day preferably as well. And I know that this is just not going to happen. It's not actually plausible or feasible for us to do something like this in an online type of class that has a virtual lab component that comes along with it. So what will happen instead is that I will be doing the lab prep. I will be doing all of the grunt work. I get to do some work for a change. Oh God, what's going on here? And then you're watching my work, and what I hope that you do is you kind of watch my technique and be like, gosh, this guy doesn't know what he's doing. I'm more of a lab person than he is. And then I also want you to pay attention to the process and the types of steps that we're doing. So without wasting any more time, I've already wasted 3.5 minutes. We're going to get into the first part of the BAC lab, and that is sample preparation. All right, so if you go in your lab directions, you're going to see, ta-da! Go get some acetone and make a solution of acetone. So I'm getting ready to do it for you. So here's the acetone jug that I picked up. And as the summer class, if you've taken the summer class, there's going to be some questions about the label information on the acetone that we picked. First off, I want you to keep in mind, oh, no. This is not the acetone in the squirt bottle. All right. The acetone in the squirt bottle is a very trashy, dirty, filthy acetone. And I hope it's happy with itself. But that acetone has contamination and impurities, and we do not need the contamination and impurities in a very sensitive method like the blood alcohol concentration. So we've got to make sure that we use super clean reagents that are high purity and very expensive. So this acetone bottle is not what we are using in your squirt bottles. This acetone bottle is kept to the side where you do not see it, and that way it is not contaminated and it stays as pure as it can stay. And it's very expensive, so we just don't want to put it in squirt bottles for you to rinse off your markings on your glassware as you begin your glassware washing. So this acetone is an ACS grade, and that ACS grade is very high purity. It's as pure as it's going to get, and it's often kind of regarded as almost like a USP grade as well. So for those of you that have taken quality control, USP is United States Pharmacopoeia, and these are pharmaceutical standards, which are very stringent and to the highest level as much as possible. So ACS and USP is often regarded as almost the same. So very high purity acetone. It costed a little bit more for this 4-liter size bottle. That's what bottle this is. You can see that there in the label, 4-liter. And the manufacturer of this acetone is a company called Lab Chem, and it probably was actually ordered through somewhere like Fisher, and Fisher just so happened to have a sale on this particular brand of acetone, and that's the one that we just picked and ordered because it was probably the cheapest. All right, if I turn the bottle to the right, if I continue to read the other side of the label that was chopped off, up here at the very top, you're going to see a lot number, and I will let you write that lot number down as well. Canvas questions are probably going to ask about the manufacturer names for these reagents, the lot numbers, maybe the size of the bottle that was used and so forth, but that's what this is going to be all about. So this is me obtaining the acetone, and we're getting ready to make the very first solution that we need for the BAC with the acetone. So in this video, that's what you're going to see me do, and we're going to walk through the process together. This is what we call an automated pipetter. It is not a volumetric pipette. It is not a micro pipette. Micro pipettes are for microliters, and by all means, these are not microliters. If you look, this is a 1 to 10 milliliter. Oh, and I will not edit that out. So bless me, everybody. Woohoo! There goes a demon out my mouth. All right, so here is a not a micropipetter. It's not a volumetric pipette either. And the reason that we don't call it a volumetric pipette is because a volumetric pipette is glassware. And it's designated for the traditional volumetric pipettes that we have in the lab. Instead, this is an automated pipetter. And it goes from 1 milliliter all the way up to 10 mils. And this is great. We keep these hidden, and the reason we keep these hidden is because we don't want you to know about them. We only have a very few, and they're very expensive, and we want you to get used to the volumetric pipettes and the micro pipettes anyway. So this is from ICA, and it's here in Wilmington, right up in North Chase area currently, kind of near Laney High School and the North Campus at Cape Fear Community College. So here is my sample prep in order to make the acetone solution that we will need. All right, guys, our very first step is to volumetrically pipette 4 mils of acetone into water, into a total of 250 mils. Well, what you're seeing here is an ICA pipette, and this is not a micro pipette, it's a volumetric pipette that is automated. And the reason I don't call it micro is because the stamp onto the micro pipetter is 1 to 10 mils. So if you can see that in the video, maybe not, but it says 1 to 10 mils out here to the right hand side. And that's why I don't call it a micro pipette, because we are not delivering microliters. We're delivering true milliliters with this type of pipetter. All right, so the way that we use these, if you've not used these before, up here at the very right-hand side toward the top of the screen is going to be a locking mechanism. So I'm going to grab this and I'm going to pull it up. All micro pipetters have that, and all automated pipetters have it, so you don't accidentally change the volumes as you need. So I'm going to unlock it, and then up here at the very top, I'm just going to twist. And as I twist, you're seeing that the just like a regular micro pipetter, the volume is going to change a little bit. So I'm going to dial this all the way down to 4 milliliters in total, because that's what my lab directions tell me, 4 mils. Now I can go get a 4 mil volumetric pipette and do the same thing, but this one's going to be a little bit more automated. Makes me feel a little bit better, a little bit quicker. It's not as troubling. So I've dialed it here to 4.00 milliliters. When I get the volume in place the proper way, just like with the other micropipetters that I'm using, I should take that and I should lock it back into place by pushing it down, and that way I cannot turn it and really accidentally pipette the wrong amount from this point. So that is the way that we use the ACA automated pipettes, not micro pipettes. All right, so in the next video, what you'll see is me using the micro pipetter to suck up 4 mils of acetone. I'm going to do a pull up, squirt back out, pull back up a second time at least, and then the directions say deliver that into a 250 milliliter volumetric flask. And I have that here. It's ready to go. So here is my volumetric of 250 mils in total.
Now, wouldn't you love to have used that in our wet chemistry class or our quality control class? Because that would have made that volumetric pipette lab so easy. But again, some people do not have those large volumes that you're seeing that we used on the screen together, because again, we're lab partners, remember? And you're just forcing me to do the work. But that's okay. That's okay. I forced you to do enough work already up to this point. Again, we've kept these hidden. We have them. We have that capability. We've always had that capability. You've just not known anything about it. So I've dialed it in to 4 milliliters, and now we need to use that automated pipetter in order to deliver that 4 mils of acetone into the proper containing flask. All right, so I'm just going to let myself keep doing some talking here in the video, and I'm going to hush here, and I'm going to turn myself on within the screen. Ooh!
All right, guys, most of you have used a volumetric pipette before and a micropipetter. So I've got my volume set at 4 mils, and I'm just going to go to the first plunger stop, and I'm going to suck up quickly 4 milliliters of acetone. And I like to squirt that back out just to prepare the pipette tip, or pre-wet it in a way. And then I go back down to the first plunger stop and slowly suck up a second or a third time if needed. As I raise the tip up, I want to make sure there's no air bubbles that happen into the bottom, and I can see that that is actually happening. So I'm squirting back down, and I'm going to set back up for a third time just to prevent as many of those as I can. That looks pretty good. And then into the volumetric flask it goes. So down to the first plunger, that gets rid of the majority of it. And then the second plunger stop, poof, out goes the plug of air. And there is my 4 milliliters of acetone that is now in the 250 mil volumetric. So we are now done with step A. The first solution's made by adding 4 mils of acetone to water in a 250 mil volumetric flask, filling to the final volume. So I'm now going to add water to this volumetric flask all the way up to where the etched line is on the volumetric. Just regular deionized water is all that's going to be needed here. I'm going to quickly do that so my acetone does not evaporate off. And then hopefully what we'll have when we get finished with that is a nice meniscus that is sitting on that etched line of the volumetric.
All right, guys, so the 250 mil volumetric flask, if you've had some of our other courses, is nothing new to you. That's very familiar. And our deionized water, in the lab area that I was working in, we don't really have sprayers in that lab, so instead we've got these big tubs of deionized water. Just as good, we fill these. They're somewhat fresh all the time, and that way they are convenient, and I don't need to go into the other lab in order to get the deionized water. So we are going to be putting that water into a volumetric flask, and that's what you're seeing here. I don't really take it all the way up to the line first. I normally put some deionized water in there and then give it a shake in order to mix it and get it in solution. And then sooner or later, I'll go further up on the neck, of course, and that is where the end of the meniscus is going to sit. So you can see the volumetric flask line. It is like right here. And the bottom of the meniscus is sitting on that line, and that is what I'm after. So I took extra care. I made sure that I added the appropriate amount of water. I didn't go under. I didn't go over. So right there, as you can see in the picture, as we go across, the bottom of my meniscus is kind of right there. If I drew my line the straight way, maybe I need a BAC because, woo, talk about walking crooked. I mean, I just drew crooked. All right, so now that that process has been done, let's see kind of what the next step is going to be like.
All right, so I've added DI water up into the line of the volumetric flask. The meniscus is sitting on that etching, so therefore I know at least close to 250 mils, if not exact, but it won't be exact because nothing's ever perfect, just like me and you. So it's full, it's ready to go. I think what most people forget, though, is that when they make these solutions, they're going to have to shake them and turn them upside down and give them a really good mix. So this is the solution for step A, and this is my acetone that's 4 mils that has now been fully diluted to a total of 250 mils of volume. So I'm going to set this to the side, and now I need to do the same kind of thing with part B, but part B is going to be our alcohols. So methanol, ethanol, and isopropanol or isopropyl alcohol is going to have to be mixed together into the same flask, and that's going to be our solution part B. So in the next video, you're going to see me get the alcohols. I'm going to do the same thing. And guess what? It's still 4 mils, so I don't even need to turn my micropipetter. It's already set. So I'm going to go through and I'm going to take 4 mils of methanol, 4 mils of ethanol, 4 mils of the rubbing alcohol or 2-propanol or isopropyl alcohol, and I'm going to add that into the same volumetric flask.
All right, so what we're getting ready to do is a mixed standard, and we call it a mixed standard because it's going to be a mixture of 3 different alcohols together into the same flask. So here in the picture, you're seeing the acetone bottle that we used before. This is just a zoomed out version over here for the acetone bottle. And it is a 4-liter jug, so fairly large, but again, fairly clean. We keep it separate. And our ethanol is very similar. So we have pulled a 4-liter jug, and that ethanol has come from Fisher Scientific. You can see their label here on the front of the label. And then, or their logo on the front of the label. And then we need probably a lot number as well. And you can see the lot number on the label if you kind of just squint your eyeballs a little bit maybe and kind of zoom in. But this is what we call absolute ethanol. And absolute ethanol, guys, look, it's 200 proof. So if you go back and think about the summer class, if you've taken that already, the proof and the percent of alcohol is related. One is double the other one. So, for instance, if something is 60% alcohol, well, you double that, and this will be 120 proof. So, if something is 80% alcohol, you double that, and that will be 160 proof. And then here, what's happening is that this is 200 proof. So, if I half that, that is 100% alcohol. That is very uncommon. And we do not use that in the lab for any other purpose. So the ethanol that's in our squirt bottles is not 200 proof. It is too clean. It's too expensive. We just need regular old denatured alcohol to use. And the reason it's called denatured is because there's contamination in it. So that way you don't drink it. That is kind of one of the reasons that they do it. So it is a contaminated alcohol on purpose. But it's still like 95%. It's still 95% ethanol, but they add a component in there in order to specifically contaminate it, so that way you have no other use for that other than kind of general lab purpose. But this particular one is 200 proof, which is 100% alcohol here. 100% ethanol is what we're using. Again, very expensive, very high purity, very high grade. And because of that, we keep it separate. So that way you don't accidentally mix it up and think that this is the ethanol that goes into the squirt bottle. No, 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 no. Neither one of these go into the squirt bottle. Too expensive in order to waste it. All right, so there's our ethanol, and just like before, I'm going to zoom in on the label, so that way you can pick apart the label information that you need. Again, the brand is going to be Fisher Scientific, and that is the logo that Fisher uses up here at the very top. The lot number, I've zoomed in a little bit more on the label, so you can record that lot number maybe a little bit better. The size of the jug is also there for you. And I want you to think about maybe the quality control course. And look at this product specification over here to the side. So it looks like if we were going to do some of the testing for quality control, here are some of the ones that we would probably do in person in a lab to see if it actually meets the grade that we have ordered or the grade that we're trying to make. So there's probably an acetone test, an assay, which means what's the concentration. Benzene test, a color test, DNase, and evaporation, identification, infrared, methanol, protease, RNase, solubility in water, blah, 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 blah. So all of these tests are part of quality control to make sure they meet certain specifications before they sell it or use it as what we call absolute ethanol. All right. Here is another picture of a 4-liter jug. And this particular picture is methanol because that's another alcohol that we're going to have to use in the sample prep. And that just as big, and it's just as expensive, and it's just as clean as the ethanol and the acetone. So this is not, again, it's not the methanol that goes into our squirt bottle. That is totally different. This methanol is super expensive and it's super clean, and we keep it to the side so that way you don't accidentally confuse it. Here's the zoomed in part of the label for the methanol jug. Again, the questions on Canvas are probably going to ask you the manufacturer. You know who that's going to be. It's going to ask you the lot number, and you can now easily see that from the label. And it's going to ask you maybe something about the grade, and that grade is listed on the label as well. And maybe even the size of the jug that was used. I don't know. You got to do some work. I can't do it all for you, can I? So all of that information is going to be there and available for you. And finally, we need a third alcohol for this standard prep, and that third alcohol is going to be called 2-propanol. 2-propanol is also called isopropyl alcohol. That is the common name for that alcohol, and it means the same thing. So prop, if you've had organic chemistry in any certain form or fashion, I don't know if you have or not, and if you do, this is going to be a review. If you don't, or if you haven't taken it, no big deal. I'm not going to ask any questions on it, but prop is a 3-carbon chain. So there's a prop. So propane, drop the E and add OL. So that means an alcohol group is located on this structure. Well, where is this alcohol group located? It's located at carbon number 2. So at carbon number 1 to the left, at carbon number 2 in the middle, I have an OH group. So that is 2-propanol, but that's also called isopropyl alcohol as a common name that goes along with that structure. So same deal, no different. And depending on how they've labeled it, it could be labeled either or. But this particular company, and you know the manufacturer of it, has listed it a certain way. So that way we know the name. The lot number is also available in that label as well. And again, the grade of the reagent can also be determined from the label. This by far is not the isopropyl alcohol that you would buy in the stores. This is way cleaner. It's purer. And the stuff that you're getting in the store is a little watered down. It's a little bit weaker. It's not the same at all. So again, we've got isopropyl alcohol squirt bottles in our lab, but at the same time, it is not this that we are putting in those squirt bottles. This is too clean and it's too expensive, just like all the others. So this is not diluted with water like your store stuff. If you need to zoom in on some of the label information, here you go. So it'll give you a better picture of the lot number and the grade. Notice over at the side, there's a product specification block. So if you've had quality chemical or quality chem and the laboratory course that goes along with it, those are some of the testing things that we were doing at that particular time. Okay. All right, so just as before, the directions are going to tell me I need to take a 4 mils of each one of these alcohols, and I need to put them into the same volumetric flask. That's how that statement is worded. So I'm going to take the same automated pipetter, and then again, I'm going to take this huge tip, and I'm going to make sure that I switch out the tips on every alcohol so I don't cross-contaminate. And I need to go through the motions of making that mixed standard. So here we go.
All right, guys, now we're working on Part B, and Part B is this mixed standard, and it says the second is made by adding 4 mils of methanol and ethanol and isopropyl alcohol to water in a 250 ml volumetric flask, filling to the final volume. So this is a mixed standard, that's what we call this, and a mixed standard is going to have all 3 components into the same flask, because we need to analyze all 3 and we can run them all at the same time. We don't need separate standards for those. So what you're getting ready to see me do is something that you're not supposed to do in a lab, but guess what? I'm going to do it because it's me. And I know that this tip is clean and I can trust myself, and I'm the only one that's going to be using this bottle, not you. So versus me pouring a small portion of this into a small container and pipetting out of that container. That is what's supposed to happen, but I'm going to save a little bit of glassware here on the volumetric automated pipetter. I have it dialed at 4 mils because that's what the directions tell me, and I'm going to stick it down into the jug of methanol. All right, so when I do that, I want to make sure I go to that first plunger first, and I'm going to suck up, and I'm actually going to squirt this out because, you know, that tip could have a contaminant. I'm not sure. I don't want to put that back into the bottle. And then I'm going to suck up again for the second time. And then I look here for air bubbles, and I don't really see any inside of the tip at all. And then now that's going to get transferred over to the volumetric flask, and 4 mils of methanol is now inserted into that. Now what you just saw me do was something very stupid, and I had methanol actually in the cap and forgot about it. So now methanol went all over the bottle, and it went all over the countertop, and it went inside the bottle probably after I just tarped and nagged about not being should not do that at all. All right, so I'm going to make sure I put a cap on this volumetric flask, and I'm going to repeat this for the ethanol, and I'm going to repeat it for the propanol in the next video.
Yeah, go ahead and make fun. I'm a little klutzy in the lab, just like everybody else. Nobody said that I'm perfect, even though I'm close to it.
All right, guys, here we're still working on our mixed standard, and I'm going to do the same thing here as well. I'm going to take my tip for my ethanol, and this ethanol is absolute ethanol, which means 200 proof, and that means 100% ethanol. There is no water, there is no contamination with this. This is straight up as clean as it can get, and that's exactly what I want to see, because I should not have impurities in these samples or the standards as I run them. So I need to spend the extra and make sure that I get this ethanol versus our squirt bottle ethanol. Just like before, I'm going to go to the first plunger. I'm going to suck up, and I don't really see an air bubble there, but I'm going to dispose of this quickly. And this absorbent pad, it's ethanol. Come on, I can do that. That's okay. These are disposable. And first plunger stop, and I'm going to slowly suck up after I pre-wet that tip. And I do not see any air bubbles into the tip. Well, there was one, so let me kind of go through that motion again, just to make sure that I really do get 4 milliliters in there exactly. That's what I'm after. All right, so I don't see any air bubbles, and I'm going to transfer this over to my volumetric flask that also has my methanol in this already, and I'm going to deliver all of that out. And there's hardly anything left over in the cap. So this time, I'm not going to make the stupid decision that I made with the methanol. It's going to be much cleaner. And then I like to keep the tips with the bottles, so that way I don't get the tips mixed up and I'm not as wasteful as I was last time. So again, I'm going to put a cap on this, and then I'm going to get our next alcohol ready, and that's our rubbing alcohol, isopropyl alcohol or 2-propanol. And we're going to add 4 mils of that alcohol into the same flask. All right, guys, we're at our last alcohol, and that is our isopropyl or 2-propanol here. Just as before, I'm going to take the cap off, and I'm going to pour some into this cap, just like I did with the other alcohols. I still have this dialed in at 4 milliliters in total, and just as before, I'm getting a little sloppy, and I shouldn't be that way. I was a little lazy in the last video, and I just dumped the ethanol out onto the Doppler mat, and that's okay. But what I did here is get a waste beaker. I should have had that in the last one, and I didn't want to pause, and I didn't want to walk away from a video that's going to be great and wonderful. All right, so I'm just going to get rid of that and waste it, and then here I'm going to place it back into the solution and slowly suck up, just like I did with the other alcohols. So once more, I look for air bubbles. I don't want to see any, and I don't. So my second pull through looks pretty good, and then I'm going to transfer that over into the volumetric, and I dispense it and get rid of it. So there is the 4 mils of rubbing alcohol or 2-propanol that I need for my standard creation that we'll do a little bit later. The rest of this I can pour back if I feel good about that, but this propanol is not outrageously expensive, so I'm just going to get rid of that too into a waste container. I'm going to put a lid on this, and I'm just going to set it to the side. So at this point, I am actually finished with my acetone and all 3 of those alcohols because I do not need them any longer. My main master standard has somewhat been prepared at this point. Now, just as before, I'm going to take water. The directions tell me to add water until you get to a total of 250 mils. So that's what I'm going to do in the next step. You won't see a video with that because I think that you all somewhat understand what I'm doing. I'm just adding deionized water until I get it to the etched line of the volumetric flask and making sure that the curvature of that meniscus is at the very, or touching the bottom of that meniscus is touching that etched line. So that's what you're going to see me do off camera. I might take a picture or 2 of it, but you get the drift. And I'll see you in the next one.
Okay. So, you know, if you really wanted, we repeat the process. So we go back to the deionized water jug. We add some water into the 250 ml flask, just as we did before. We make sure that we mix, and then we top it off, and then we mix again. So the directions or the prep for that part is identical, and it's just the same as what was there before.
Okay, we're moving on to the next step, and the next step says, okay, now that you have this one and this one made, you need to take 20 mils of this one and add it to a flask, and take 20 mils of this one and add it to the same flask, and dilute to the line with water using deionized water, of course. All right, so this is now a combination of the 2 that I have prepared earlier. So what I've got here, I've already mixed them, I've already diluted them to the line. They look really good, and I'm just going to pour some of this out into a beaker, so that way I've got a little bit more freedom. I can feel more comfortable about pipetting from this solution. Okay, so I'm going to go grab a tip. Hold on. And I need to take my automated pipetter, and this only goes to 10 mils, and I'm going to need 20 of them. So I'm going to pull back and unlock it, and then I'm going to dial up until I get to the 10 milliliter mark. So as I keep turning, that number keeps getting bigger and bigger, and I'm going to get to 10.00. Now this cannot do 20, right? But we're going to do 2 portions of this, and that will add up to 20. So I'm going to push that back to lock that in place, so that way I feel a little bit more secure. I also have a waste beaker still over here. I'm going to set that to the back. So that way, when I push down on the first plunger and I suck up the first 10 mil portion, I really like to pre-wet that tip. And if I can waste that, that's great. I'll just dump it back here. I get rid of it. I don't use that for anything at all. So now my air bubbles will not be as obvious, or they won't be as problematic in the next sample pull. All right, so I'm going to slowly pull up 10 milliliters, and I look at the tip, and I see a little air bubble down here at the bottom. So I'm just going to squirt that back out, and then I'm going to try it again. All right. So they first pull. If there's any contamination in the tip, I'm getting rid of that. I'm not contaminating anything. The second pull, I'm just really looking for air bubbles, and that's really it. So I'm going to sit here and kind of finagle with it until I can really get a good pull. Now I need 2 pulls of this, because again, I need 20 milliliters. There we go. So there is my first 10. And now I need a second 10 because it tells me I need a total of 20. Now you could, if you wanted, to use a volumetric pipette and pick a 20 milliliter volumetric pipette and come in and do this work, and that is perfectly fine. But I need something a little more automated that I can more easily handle, I guess. And I'm going to put the lid onto that volumetric. And then I like to keep the tip near the original container, so that way I know where that tip came from. All right. Okay, so now I need to do the same thing in the other one. So I'll set that beaker back, and I'll put this one to the front. I've already filled this to the line. I told you I'd do that off camera, and I did. I added deionized water up into the point of the etched line, so it looked pretty good. Gave them a really good mix, so that way it was ready for me when I needed it.
Listen at me rustling.
All right, a new tip, because it's a new solution. And again, I've set it at 10. I need 20 of this one as well. So the first suck up is going to be the disposal. Get rid of it. Contamination could be there. All right, so first plunger, slowly suck up, just like before. Have fun. Yay, yay, yay. I don't see any air bubbles with this one, so I'm going to quickly transfer it to the volumetric. Put the lid back on. These are alcohols and acetone, so they will evaporate on me if I don't keep the lids on the volumetric. And that also looks good. So that was a lucky one. And there we go. All right. So now that 20 milliliters of each one of them has been added, I'm then going to move on to the next step. And the next step is going to say, add water to this volumetric, take it up to the line, and you will have a total of 250 mils of this intermediate stock standard is what they're calling this. All right, so that's great. That's what I'll do again off camera. I'll take this to the line with 250 mils of water. I'll give it a really good mix, so that way in the next video, this is now ready to go.
Boring. I know that's what you're saying. Boring. Blah, 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 blah. All right. Well, okay. If I have to go back, guess what, folks? We went to the deionized water jug. We put some water in the flask. We mixed it really well. We diluted those alcohols even further by doing that. And then we go up to the line that we see on the volumetric flask to make that sample. So now we've got something a little bit more appropriate that has been weakened down to the point that is getting us a little bit closer to the standards that we need to end up making. All right, so in the next step, what they're going to tell us is that we're going to have to make what they call an internal standard. So the purpose of the internal standard, if you've taken the standards and solutions course, we've talked about this already, but the internal standard is here to really check the instrument performance. It is not to check your performance, but the machines. You are not doing the injections. The instrument will be doing the injections. So we've got to have something in place where we can make sure that when that instrument did its job and prepared the sample and injected the sample, that it all went smoothly according to plan. And that is the purpose of the internal standard. So we talked a little bit about how to handle internal standard calculations. That's going to be a little bit later on in the lab videos that you're going to see with me, which is perfectly okay. There's no rush, whatever, but the internal standard is going to have to be prepped. Two things with an internal standard. Number one, it cannot be found in the traditional samples that are submitted to the lab because you're defeating the purpose. If it is there in the sample naturally, then by the time that you get it into the machine, that is going to add on top of what is already there. So again, that does not make sense. We've got to pick out something that is not going to be in the blood sample from a person in order to use that as an internal standard. The other criteria is that it should be very similar in structure to what we are measuring. All right, so all of these, methanol, ethanol, isopropyl alcohol, the acetone, blah, 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 they have a lot of OH groups on them. Acetone, maybe not, but all the alcohols, yeah, absolutely they do. And the alcohol is what we're trying to find. We want blood alcohol concentration, specifically from ethanol. So what kind of alcohol would not be present in a human blood sample naturally? Just absolutely no way possible is it present in a blood sample. And give me something that is very reasonable in cost, because we don't want something so specialty that it takes an arm, a leg, a kidney, and anything else that you can sell in order to purchase that reagent. And for us with this particular method, it's actually propanol. And propanol starts with a N, and that N stands for normal. So what propanol is a prop 3-carbon chain, and N is normal, so the normal version of propanol, which means it happens on the first carbon or at the end of the carbon chain, right? That is the structure of propanol. Not fully, because just like with the other ones that I did not draw, carbon has to have 4 bonds, right? So here we're giving carbon 4 bonds all the way around. So there is my CH3, CH2, CH2OH. 1 propanol, aka N-propanol, or like the label says, N-propyl alcohol. Right? There we go. That's it. So N-propanol is not going to be found in a human blood sample. There's no resources that a person can use normally that can get a hold of N-propanol and ingest it and have it show up in their blood sample that we take from them. Methanol can be there. And the reason that methanol can be there is because that can be a byproduct of the ethanol production. Think about the moonshine lab that you did in the summer if you've taken that class. Methanol could be a contaminant, and it's a natural contaminant, and that's why we distill it, so that way we can get rid of that contaminant if it's present. Ethanol, ETOH, well, that's good old-fashioned drinking alcohol. That's what we're going to be testing. That's what we're going to be running. Woohoo! Yeah, yay! I'm Beverly Hillbillies, and I'm Granny. Look at me. And then the IPA. Why IPA? Goodness gracious. Well, believe it or not, some people use rubbing alcohol and they try to drink it and they try to get drunk off of it because it's cheap alcohol. So this is something that people do, and IPA could be in your blood sample as we run it. So definitely IPA we can look at, we can measure. We're doing some of the other alcohols anyway, but IPA can be part of a blood sample taken from someone. That is why it's not an internal standard. Ethanol is what we're looking for. That's why it cannot be an internal standard. Methanol is something that can be present in a blood sample, whether it's deliberately or not. It does not matter. It can show up. It cannot be an internal standard. An internal standard has to be something else that naturally should not be there most of the time that we run these, right? That's what this is all about. That's the proper definition of an internal standard. So here we go. Sapelco is the manufacturer of this reagent. And OmniSolve is the grade of the reagent that we are using. So super pure and a little pricey, a little expensive. And then, of course, we probably need the lot number at some point in time. So the lot number here is going to be in the top left-hand corner. A little bitty, tiny, weeny writing says lot up underneath the 6. So that is the appropriate lot number that we need for this reagent. Also notice it says it's appropriate for HPLC, any kind of spectrophotometric analysis, and gas chromatography as well. All of those instruments require super sensitive, high purity reagents, and here the label basically tells us that. So we're good to go. And the prep work of this particular sample is not actually volume based. The prep work here is mass based instead. So that's what you're getting ready to see me do in the next video.
All right, so the next step is the creation of the internal standard. And the internal standard is a solution that I am using in the laboratory analysis to make sure that the machine is performing the proper way. That's the only reason that we're using internal standard. I'm not injecting it. I have to double check the machine is checking it the proper way, and this is how we're going to do it. So in this lab procedure, it says use N-propyl alcohol. So here's N-propyl alcohol, and we need to add this time gram-wise, not volume-wise, but it says 1.5 grams of N-propanol in a liter flask. All right, well, great news, because I've got a balance that goes all the way to 520 grams. So I'm going to take this 1 liter volumetric flask, I'm actually going to place it onto the balance, and guess what? It can do that. Now, when I do this, okay, yeah, it's going to weigh a little bit, whatever. I need to tear this out. Just like before, I just tear out everything. I mean, that's not surprising. Surprise, surprise. All right. And then I need to take the N-propyl alcohol, and I need to add 1.5 grams in total. All right, well, I'm actually just going to do this straight from the bottle. It's pretty full. Again, it's very clean. If that makes you uncomfortable, I can pour some into a little tiny cap, and that's all right. It's not going to take a much, but I need 1.5 grams. So I'm going to suck up some into the transfer pipette, and then I'm going to add it to the top of the volumetric, and I'm just going to add drops at a time until I get to 1.5 grams in total. I don't know if you can see this or not, but as I'm adding that alcohol to the volumetric, it almost looks like it's bubbling. How cute. How surprising. Great. Yay! All right. So I'm just going to transfer as much as I can, and I'll get a total of 1.5 grams. Patience, my friend, patience. So right now I'm at 0.9. I'm at 1.2. As long as I get about 1.5, I'll be okay. Again, it's an internal standard. It's not part of the proper standards. It's just a double check of the machine. 1.5 is going to give me something that's going to be, you know, okay on the instrument, okay with the signal, on par with the other things that are there. In 150, if you've taken that class, you've learned that an internal standard is something that should be structurally similar. So this is an alcohol, just like all of the other components that we're looking for, methanol, ethanol, and so forth. And it should not be found in the sample at all, because that will give us a problem if it is. And we should not be having access to propyl alcohol at any point in time. So it should not be part of a sample that we analyze in a laboratory environment. So here, I'm going to stop. I'm just quite shy of 1.5, but that's okay. And the reason is because as long as we're in the ballpark, this is going to stay the same. It will give us a readout, whatever readout that might be. Who cares at this moment? But I am close enough to 1.5 that I can feel really comfortable and say, all right, this is going to be pretty good. So I'll take a picture of what the final volume is going to be. It's drifting just a little bit right now. That's kind of going to be expected because it is an alcohol, but it should not evaporate quickly on us. It's not that volatile like acetone would be. But I'm going to kind of let this settle down. I'll take a picture of how much is actually here by the time that it does its job.
All right, guys, so notice what I said. The amount, as long as you're close, you're okay. And the reason is because We just want an internal standard that's going to be present, that can be picked up, and the concentration kind of doesn't really quite matter. It just needs to be consistent from injection to injection to injection to injection. So whatever we end up with, as long as it's close, we're going to be fine, because we're actually looking at how the signal is going to be showing up in the machine. So if it's a little bit lower, who cares? We're looking for consistency. That's what the internal standard is all about. So as I gabbed, I left the lid off. And by the time that I got the lid, and by the time that I kind of went back to the volumetric flask, this is going to be the mass of the propanol that we have used for the internal standard. So you can write that number down, and that value is going to be used sooner or later in our spreadsheet that we're going to have to create. And you're going to also see probably a Canvas question or an online question concerning it as well. So with that particular internal standard, that was going to be in a 1 liter flask. So just like before, I've added some deionized water into the flask. I filled it about half, and then I'm going to swirl it and mix it and get everything somewhat incorporated. And then sooner or later, I'll take it up to the etched line on the volumetric. So the etched line of the volumetric is right up here at the very top. You can kind of see that. And that was my next step that I did not take a picture of. But side by side, my 2 samples are now prepped. So what I'm seeing here is the standard that I will use to make everything else with. So this is the proper mixed standard that we are going to be using for our standard prep. Over on the right-hand side, the 1 liter flask, this 1 liter flask is going to be used for our internal standards. So this is going to keep track again of the instrument, making sure that it's injecting the proper way as I walk away and let that instrument do what it needs to do. All right, so these are the 2 components that we're going to need for our standard preparation. And then here we're seeing just a close-up picture of that, again, just to prove to you that I did take it up to the line. I did what I was supposed to do. And then I actually spoke a little bit ahead of myself, because the 1,000 milliliter flask, this internal standard, I think is actually too strong. So in the next part of the lab directions, it's going to say weaken that down. But either way, here is my mixed standard that I've made, and here's the internal standard, original internal standard that I have done after that. All right, here's a picture of the 500 milliliter flask that's going to have to be used. This is a dilution of the internal standard that we're going to have to do. So I've grabbed my 500 milliliter, and now we need to make that dilution. All right, and that's what this video is going to show you.
Okay, so what I've just made is the 1.5 grams of propanol and added it to the 1 liter flask and took deionized water and took it up to the line of the volumetric. So this is ready and it's prepared. But if I go and read the next sentence of that statement, it says then, ding, 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 then 50 mils of that solution is added to 500 mils volumetric flask and dilute it to the line with water. And that's because that 1.5 grams is way too strong in this 1 liter of solution. It's got to be weakened down again for our instrument. So just like before, I'm going to take our volumetric pipette that is automated, and I've dialed it in at 10, which is the maximum, and I'm going to deliver 50 milliliters of this stuff into that 500 mil volumetric. It's okay. I mean, I have to do this 5 times. I don't have a bigger automated pipette for that, and it's not a big deal. It's just going to be 5 motions of it, so whatever. All right, so I'm going to suck this up. This is a new tip that I have used, so I'm going to get rid of that, and it's just a little bit of alcohol, and it's some water, so it's not terribly expensive. I can do that. I feel really good about it. And then here is going to be my first 10 mils in total, and I just got to do that 4 more times. So there was 10, and 20. Most of these are water-based now, and a lot of that water is going to cause me not to have problems in the pipetting. There's traditionally no bubbles that begin to happen in the micropipette tip. There's 30. And that's great. The alcohols, anything kind of volatile, that will do that. But when it's mainly water as the solvent and there's very little alcohol and stuff present, I normally don't see that problems go on. All right, so there's 40, and this will be my 50 pull. So I have added 50 mils of that solution into the volumetric flask. All right. So now what's going to happen is that I need to take this internal standard and I need to dilute that with water up to the 500 ml mark, just like all of the other standards that I have done. So I had a little bit of water in here in the beginning just to catch that alcohol as it was getting delivered, and I'm just going to take deionized water to the etch line. And I'll give it a good shake before I take it up to the line. I'll give it a good shake, and then I'll top it off and I'll give it a good shake again. So same as sample prep as always, nothing special at this point, but this will give us our appropriate concentration of internal standard that we need to add into all of our standards after we prepare them.
All right, guys, so that is the actual working internal standard that we've just prepared. Again, I'll take that to the line with deionized water, give it a really good mix, and then set it to the side for our standard prep. For our standard prep, the directions actually say make these in 100 ml volumetric flask or 100 ml total volumes. And that's what you're seeing here. It's just an assortment of different 100 ml volumetric flask. For our standard 1 and 2 and 3 and 4 and 5 and 6. So this method does require a total of 6 standards, and we're going to have to go through that process together. And I'm going to lead you through that process because you are my lab partner, and we need to watch this together, and we need to do this together, and then we're going to answer really nitpicky questions in Canvas or the online platform as far as the assignment relation goes. All right, so in this video, you're going to start to see the beginnings of that standard prep. And you can see my 6 100 ml volumetrics lined up side by side, nice and orderly. I just wish all the labels were facing in the same direction, but they were not. And then here's my 250 ml mixed standard in front. And that is the acetone, the methanol, the ethanol, and the isopropyl alcohol.
All right, guys, so in the next step, it's going to ask me to make a calibration set, and this is going to be a set of standards that will go really weak in concentration to really strong in concentration, with the idea that we need to make sure that we understand that blood alcohol concentration should hang out at 0.08 or lower in order for it to be legal. So we're going to kind of hit that 0.08 somewhat in the middle, and we need to make something a little bit higher and something a little bit lower, so that way if we run blood samples and they don't have any alcohol in them, then the low calibration standards will work for those. But if we get somebody that's really drunk, plastered out on the Wilmington sidewalk one Friday or Saturday night, well, they might run higher than 0.08, and because of that, we need to make higher calibration standards for that reason. As before, I'm going to use our automated volumetric pipette in order to make these standards. That way it will make my job a little bit easier and a little bit faster. The other nice thing about this is that at this point we have what we call a mixed standard, and a mixed standard basically means that all of the alcohols that we need to be analyzing for are in one volumetric flask. So I'm not pipetting multiple alcohols into each one of these flasks. We've got methanol in here, we've got ethanol in here, we've got IPA that's also in here. So for that reason, everything is kind of ready to go, and we should just be able to pour some of this out, and I should just be able to deliver different volumes of these solutions into each one of these flasks. So that's the purpose of why we do mixed standards. Makes it very convenient here in the very end when we make an entire calibration set. All right, so just as before, I'm going to start with the lowest one actually, and the lowest one says I should take my intermediate stock, which is this one that has all of my alcohols in it, and I need 2 milliliters in total. So I'm going to pull back and unlock it, and I'm going to dial to 2.00 mils, and then we'll just work it from there. I'm going to think that that's going to be a little bit easier for me. I don't have to keep, doing crazy stuff as far as the standard prep goes. So I'll dial it in to 2.00. All right, so I'm almost there. There we go, 2.00. I'll lock that back into place. And I'm going to take a waste container that's here, and I'm going to go down to the first plunger stop and get rid of that. And I'm only going to do that the first time. That's it. That's all I should be able to do that for. And then 2 milliliters in total gets added into that volumetric. All 3 alcohols are present in that volumetric. I put a cap on it so it doesn't evaporate, and now that calibration standard is now done. Next up is a 5, so I'm going to pull back and I'm going to dial this up to 5. Now I tend to actually suck up, just as I did before, and get rid of that first pull. And the reason is because the solution's going to go further up the tip. And if that tip is not completely cleaned out, and maybe there's contamination like way up in here, well, I only did 2 mils. I only had liquid that went up to right here. It's not coming in contact with any of this contamination that might be present. So I'm going to lock that back into place just as before, and I'm going to pipette 5 milliliters into the next one. So as before, I'm going to suck up, and that went further up into the tip, and I'm going to get rid of that one. Just in case there was stuff that was up into that pipette that made its way there, and I had no clue it was. Well, now I'm kind of rinsing that out. All right, so 5 milliliters have been prepped for that one. Next is 10 mils. So now we're at the top of the automated pipetter. I can't do higher than 10, but I can do multiples of 10 if that's the thing. So I'm going to dial it up to 10.00. And there we go. So I'll lock that back into place. As before, first plunger stop, suck it all the way up. It'll fill that micro pipette tip up at this point, and I'm going to get rid of all of that. All right. All right, so I'm going to repeat that process. Go slow. No air bubbles. 10 milliliters goes into that one. Dispense it all. And there's my third calibration standard. Now, not quite. I still have to take these to the line with deionized water. But those are my first 3. My 2, my 5, and my 10. So now I'm going to kind of repeat this process for my 20 and my 35 and my 50. And what you're going to miss out on, I don't think you need to watch that process. But for the 20, I'll just do 2 shots of the 10 mils into that one, cap it. And then I'll do 3 shots for my 30, and then I'll dial this down to 5 to do 35 in total. And then in the last one, I'll do 5 shots of the 10, which gives me 50 mils in total here. I'll take them all up to the line with deionized water because that's what it tells me to do. It says, using the amounts above, prepare a series of standards, and each standard should be prepared in a 100 ml volumetric flask. Okay, so I'm going to take them all up to the line with water, put a cap on them, give them a really good mix, and then that way my calibration standards are almost ready to be ran on the instrument. All right, so I'll stop the video here, and all of this will be prepped by the time that you see me again.
All right, guys, so not really difficult to make the set of standards here. Again, it's all about keeping our volumes straight, making sure that I am adding what I'm supposed to be adding into each one of these flasks. And then really, truly adding some water, mixing, and taking it up to the etched line on every single one of these takes a little bit longer because you've got to be really careful. You want to make sure that you are preparing these the proper way, and you don't want to overfill it or underfill it because a few drops can actually make or break you here, just like in many of the other lab activities that we do. So now that that has been finished, here is my setup. And you can see all of my standards are to the lines back here in the volumetrics. And I've got a couple of extra micropipetters here in the front. And also have some containers that we're going to be using over here in the blue tray to the right-hand side. So I'm going to have to talk to you a little bit about the headspace containers that these standards are going to go into. And one of the very first things that I need to show you is this one. So 2 different types of headspace vials can be used in a lab, and here they are.
All right, guys, so we're getting ready to put our calibration standards in headspace containers, and there's two different types of headspace containers that are out there on the market. One is to the left, and this is a screw cap that is threaded, and we use these particular types on our Shimatsu headspace system. And then the other one is a more traditional crimp type of lid on the headspace containers. The reason we use the one to the left on our Shimatsu system is because these lids are magnetic. So that's how the autosampler works. It actually takes a magnet and it latches onto the top of this and it picks it up like that. It is not a grabber or a grab machine. Have you ever watched that movie, The Grabber, or Black Phone? It's a little bit different, and I'm just going to show you how we would crimp if that's what we were getting ready to do. So I would just take a container, and I would have my sample in here, of course, and on top is going to be the lid. So I'll just place the lid on top of the sample container, and then this is a crimping device. It's a manual crimping device. It just sits down on top as snug as it can go, and then you'll just squeeze the handle, and what happens is that it takes that lid and it tries to completely seal it all the way around. So you can see that it has crimped the lid, so that way if I turn this thing upside down, the lid cannot come off. Any liquid on the inside hopefully will stay on the inside. These are supposed to be gas tight, which means that once sample goes in, nothing can really volatilize out and leak, but it can still happen if you're not careful. So if you're not crimping these the proper way, you have a loss of sample, and that's why a lot of people prefer the crimp style over the threaded one, because they believe that once you thread this on, this is not a leak-free connection, that the threaded lids do allow some volatile fumes or that kind of thing to escape over the course of the analysis run. So as long as you're crimping them kind of tight, you'll be okay, but this is what our Shimatsu system uses, and that's what we'll have here. So what I've done is that I've brought in some headspace containers. I have a total of 6 because we made 6 standards, and the directions are going to say you need to put some standard into the each one of these containers, and you need to put the internal standard also into each one of these containers. Keep in mind, I've already made different standards. They're at different concentrations, but we need to be very particular about how much of these standards that we are going to add into these headspace containers. So there's going to be a total of 6, and I just kind of like to line them up like this. I definitely do put the caps on them after I prepare them, so that way nothing can escape, nothing can be volatile, and all of my samples stays into these containers for sure. All right, but those are 2 different types of headspace containers that you see in our lab. We do use both because our Agilent systems use the crimp tops, not the threaded ones. All right, guys, it's time to make our calibration points together, and these standards are really just 2 shots, one from the actual mix standard and one from the internal standard. So the directions are going to be pretty simple. It's going to say take a headspace vial, and there it is, and it's going to be 100 microliters of the standard. All right, so here's an Edvotech micropipetter. This goes all the way up to 1,000, and I have already dialed it in at 0,100, so that is a 100 on the Edvotechs. So I need to add 100 microliters of a standard into this headspace container, and then it also says you're going to add the internal standard into that same component, and you need 1 milliliter of that internal standard. All right, so here's the Edvotechs. Just like before, I'm going to push that gray button up, and that will unlock it, and I'm going to dial it up, and I go all the way up to 1,000 because on the Edvotechs it is a direct readout. So I'll go up to 1,000 in total, and that is 1 milliliter that I am getting ready to pipette. And I need 1 milliliter, and then I need to lock that in place. So I'm going to push down that gray button right up here at the very top, push it down, and that will lock it. So I need to add 1 ml of the internal standard into every single sample container, and then I need to add 0.1 mil or 100 microliters of my standard into each headspace vial. All right, so let's kind of make these together. I've pulled out my first calibrator here, my first standard. So I'm going to place the tip in, suck up, and I've got a waste container over on the side. So I'm going to suck up 1 or 0.1 mil of standard. Folks, that's all that I need. And then over onto the side, I'm going to pour my internal standard into a bigger container because I'll need 1 milliliter of that one every single time. Remember, internal standards will be the same amount every single time that you use them. So that's my first kind of pull up with a pipette tip. So 1 mil gets added in, and that's all that I need into that container. All right, so I'm going to thread this on as tight as I can get it, and my first standard is now done. All right, so I'm going to set that one over to the side. I've already used it, and now I go to my second calibration standard. Same as before, I just need to remember, switch out my tip. All right, so I'm going to get a new tip, and I need to suck up, waste, and I need to suck up another 0.1. I'm going to add it to the headspace container. And then it's the same propanol, so I don't need to switch out tips. I don't need to waste tips. Oh no, that's okay. That's all right. I've already added my standard, but my standard is now ruined. So if I need that standard again, I'll have to go back and remake it. Look at me making all of these mistakes today. Shame on me. All right, so we'll thread on the lid, and there is standard number 2. All right, so standard number 2 is now ruined because I've accidentally added a little internal standard into that. So the data won't make sense. I'll have to remake it if that's what I want to do. All right. Okay, so I'm going to go on to my third one. And just like before, I'm going to take my headspace container and I will suck up 0.1 mils, get rid of it, and then I will suck up more. And that will be delivered into the container. And then same propanol as before, no need to get rid of any of that. Same tip is okay. I add that into that container and I'll put a lid on it. All right, I'll make it to standard number 4 now. And I just repeat the process, folks. That's all that I do. This is how I make the standards for the blood alcohol concentration. All right, so new tip. Suck up, get rid, 0.1 mils, super tiny. There was an air bubble there. Super tiny with that huge big volumetric flask that I've made instead. It's kind of sad. It's kind of pitiful. All of that work I did just for a 0.1 smidge. Well, that's how it goes sometimes. All right. Okay, so there's number 4. Number 5, again, I just repeat the process. New tip, new standard. So, 0.1, get rid of it. 0.1, looks good. No bubbles. And then 1 mil of the internal standard gets added. These volumes have to be kept constant, and the reason is because it is based on how much it releases. So if your volumes are not constant, there's going to be more of stuff in there, and more of stuff means more vapor and more that the machine's going to pick up. So you cannot, by all means, just add whatever amount of sample that you want to add in here. It is not going to work that way. So all of these have to be pipetted or micro-pipetted into the sample containers. All right, so there's my last standard of 0.1, and then my internal standard, that had an air bubble. My internal standard, my last shot, and a lid goes onto that one. All right, so my standards are now prepped. That's all that I have to do, really. I've just added my standards, 0.1 mils, into every container, and I've added my 1 ml of isopropyl, not isopropyl, but propanol or propyl alcohol into each container. And this is how much I end up with right there. Little tiny weeny weeny smidge. That's it. 1.1 mils is all that my standards are going to hold. So those are going to get loaded up into the machine, and the machine's going to take over at that point. But I'm finally done with my standard preparation. Thank goodness. All right. So now we need to prep some samples, and you're going to see that in the next video.
Woohoo! We're done. Well, no, not really, because what I decided to do after I ended that video is to duplicate those. So, you know, most of the time this is what's done in a real laboratory setting. We like to run duplicates, especially with processes like this. And what I did is that I went through and remade the standards all over again in the same fashion. But keep in mind, I did remake number 2, so I had to start off with a new number 2. And I went through and just made a second set of standards. And I labeled these as B. So what you'll find on the report is a set of standards 1, 2, 3, 4, 5, 6, and they probably will have A's after them. And then you'll find another 1, 2, 3, 4, 5, 6 with B's after them. They are the same standard. They have just been duplicated. That is it. So normal processes here is that we take averages of these values and we'll use the averages to do our calibration work with. All right, so now that we've got the standards out of the way, we now need to focus on samples. And these are blood samples that have been taken from a real person, a real living, actually, person. Oh my God. So let's see how we treat the samples in the prep for BAC.
Okay folks, so we are now ready for our sample prep, and what you're seeing here are blood samples from real people, real blood. Yes, that's what we're using, and we're going to test a total of 5 samples today, and I'm going to prep them in duplicates. So that's why you see so many headspace vials here that are lined up ready to go, because I'm going to run and prep one sample, and then right after that I'm going to do it again on the same sample, make a duplicate set, and then that way we can do an average. We hope that these numbers get really close as we run them, but there's a chance they might not. So that's kind of why we're doing what we're doing. I'm not going to go through the entire kind of repetitiveness that's going to happen here, but I'm going to at least prep one for you in duplicate, so that way you can see how this process is going to work. Back here in the large volumetric flask, this was my internal standard, so I'm going to pour a fresh portion of that internal standard in that beaker. I don't want that to evaporate off. I don't want the concentration to change, so I always like to top this off fresh whenever I do standard preps and then sample preps. Here are 5 samples, 1, 2, 3, 4, 5. We're going to analyze all 5 for BAC level. And then on our headspace containers that you're seeing here, they're going to be labeled as S for sample, and then 1A and 1B, so that way you'll know which one is which. So I'm going to start with the first blood sample. Here's the blood tube, and I'm just going to shake it a little bit, just like that. And if you can prep the standards, you can prep the actual blood samples as well. What we've done here beforehand is we have given them a little jiggle in a vortex, and I just like to give them an extra little jiggle here before I use them and prep them. So what will happen is that in this BAC analysis, we inserted 0.1 milliliters of standard into headspace containers, right? So we're actually going to do the same thing here. So I'm going to take this top off. Blood! All right. And then what will happen, and my ones are back here in the back of the tray. So what will happen here is that I will take this blood sample and I'm going to pipette also 0.1 milliliters of that blood sample into the headspace containers. So I'm going to not touch and squirt directly into there if I can. And then I'm also going to do this again. Blood is a little bit thicker, so you're going to see it contaminate kind of the tip and stuff. It's okay, we know that. And then I'm going to get rid of that micropipette tip. All right. So on the top of the blood tubes, I want to make sure that I secure them so that way they don't turn over. And then just as before when I made my standards, I'm going to micropipette 1 milliliter of our internal standard into each one. Right. Now, I don't have to work as quickly as my standards, and that's because the blood actually is not going to evaporate off. Now, I do want to work kind of fast. I don't want to kind of be a turtle, but I do want to kind of go through and make sure that I am prepping them as best as possible, but also in the short amount of time. All right. So then I give them a good shake. And there is our SA1. So that is actual real blood from an unknown person. And I'm going to set this to the side. I know I need to run it. And then this is going to be the duplicate of that one. So S1B. And then again, I'm going to shake. I'm going to make sure it's mixed. And then I'm going to set this to the side. And we will insert that into the auto sampler tray. So with a new tip, I'm then going to go to number 2. Again, give it a shake. Make sure that all of that blood is nice and juicy and mixed. Yum, yum, yum. And then I'm going to, I have a new tip here, so I'm going to insert 0.1 milliliters of blood into that tube. And 0.1 mils of blood into the next tube. The majority of this red that you're seeing is actually on the outside of the tip, not on the inside of the tip. So, you know, if you watt that off, that would actually, the majority of that would actually come off of there. So you're not leaving too much behind, in other words, inside of the tip as we transfer. All right, so 1 milliliter of internal standard into each one of those headspace containers. Again, just in case the auto sampler messes up, then that way I know that I've got a backup if I need it. All right. So again, shake, shake, shake. And there's S2B, nice and juicy and red. It's apple red almost with that one. Looks a little different than the other one. All right. So again, a cap, give it a shake, make sure everything gets mixed, and then I'll leave it over to the side. So what you're going to see in the upcoming samples, and I'm not going to record that, I'm going to just repeat the process for sample 3, 4, and 5. And then we're going to put these onto the instrument sooner or later, but this is the difficult job of preparing samples. Again, if you can do standards, you can do samples, that's not a big deal, and it's just as easy as this. So same amount of standard and same amount of sample has been used in all of these headspace vials, and the same amount of internal standard back here in the back has also been used in every single headspace vial.
All right, guys, so just like I said, everything volume-wise has to stay constant throughout the headspace analysis. So it's the same amount of standard, the same amount of sample, 0.1 across the board, and the same amount of internal standard in every single one of them. So everything has to stay consistent because we are relying on that solution to free up the alcohol that might be present and release it. And if we start doing different measurements of samples and standards, it's not going to quite make sense. So we really have to be kind of on target with our target or our volumes that we're using. Here's how I've labeled the samples. So this is what's going to show up on the report. So sample 1 and then A, and then sample 1 and then B. Again, we're running everything in duplicates just in case there is a problem with one of the sample injections. And that way we don't have to go back and remake or redo anything on a completely different day. So it's always a good idea to do duplicates whenever you can. All right, so now we've got our standards made, we've got our samples made, but there's still something else that we need to do as well. So here we go.
Okay, so now we need to prepare our final kind of samples that we need to run on the auto sampler, and that is our quality control samples. So this is something that the lab has made. They know what concentration that is, and I don't. So I'm going to, and really deep down I do. So really we just need to prep these just like we did our standards, just like we did our samples. It's the same volume for everything, and just as before, it took me a little bit of time to get these and to prep everything else before. So I'm going to pour a new portion of internal standard into a container, and just like our standards and just like our samples, it is 1 milliliter of an internal standard into each sample container because everything needs to be ran on the machine. So we cannot change those volumes out at any point in time. I'm also going to prepare these in duplicates so that way if one messes up, we've got a backup that we can go with. And as before, 0.1 mils. So 100 microliters of, excuse me, of standard and 100 microliters of blood sample is what we've been using. So 100 microliters of the quality control sample is going to be used to make this duplicate. So again, everything stays consistent. All of my volumes are at this point 1.1 mils, just like my blanks, and now my QCs are prepped and they're ready to go. So I've got a set of standards in duplicate, I've got samples in duplicate, I've got multiple blanks, and now I have quality control samples that are also in duplicate.
All right, so if you paid attention, I said multiple blanks, and that really hasn't been shown up in the video yet. The reason is that I don't think that I recorded it because it was a simple process. I just added 1.1 mils of water into a handful of different headspace containers, and I've just added it to the set. So that way, just deionized water, a couple of those can be ran in the beginning, a couple of those can be ran at the end, and then a few more can be scattered in the samples and in between the samples and the standards. Just to keep everything clean, to make sure there's no carryover, contamination, and so forth. But folks, it was just 1.1 mils of water added to a headspace container. And I did, again, a handful of them. And we'll run those, and those will be part of the data set. You'll see those reports that will come from the blanks, and I did label the blanks as B. So B1, B2, B3, B4, B5, B6. So S for samples, the QC for QCs, and then we did our standard prep, and then we did some blank runs. All right, so that's what's eventually going to go onto our machine, and this is what our machine is looking like. So this is our Shimatsu headspace system, but it's also a liquid injection system at the same time. A few pieces and components that I need to talk about as far as the instrument goes, so you know what you're looking at here. On the bigger box here in the middle of the screen, this is our GC box. So this is where separation is going to take place, and our acetone and our methanol and our ethanol and our propanol and isopropyl alcohol, all of those are going to be separated one from another, and that happens inside of the GC system. Over here to the left-hand side of that box, this is our hydrogen generator that we have in-house. So that hydrogen generator's purpose is to produce hydrogen, and that hydrogen will then be used to feed over into the FID detector, or FID. To the left of that are these GC gas tanks. And these gas tanks, it's an assortment of tanks. So one of these will be helium, one of these will be air. I think one of these are hydrogen, and that hydrogen tank is really just present for a backup in case our hydrogen generator goes bad. We have a hydrogen source that we can use. The air is going to be required, so the air is also pumped into the FID detector in order for it to light a flame and for it to do its job. And then the helium is used for the mobile phase. So something's got to push everything through the GC. When I add sample into that instrument, something's got to push it through. And that is our helium gas that we've decided to use here for our GC Shimatsu system. So here's a closer look of the hydrogen generator. The manufacturer here is Parker. You see that up at the very top. It says FID gas station, and it does generate hydrogen and it does generate air if we want it to, but we've decided not to use it that way. But it is making hydrogen as needed on the spot. And it uses some oxygen gas too if we need to, but hydrogen generator is there. These hydrogen generators cost anywhere between $10,000 to $15,000 a piece. So that instrument is just filled with water. That's all that you got to do with it. And then you flip the on button and you allow the generator to do what it needs to do. And it takes that water and a little bit of electrolysis and it makes H2 gas and it makes O2 gas. So it decomposes water into its elements of hydrogen and oxygen. Here's a different picture of our Shimatsu GC system. GC 2014 is kind of the model number of the GC. And it is capable of doing liquid injection. And I would say that liquid injection is more like normal injection for a GC. But we are getting ready to use it in the headspace version. And that's why we've bought this instrument. It's for the headspace piece. So that is our GC system. We have FID detection on this. And it has headspace as well as a liquid injection for that. So again, this is the two components really that is connected together in order for it to do its job. Over here to the right hand side, this is the CPU unit. That's the computer and the software that operates everything. And then up on top, what you are not seeing up here, it's out of the picture because this machine is so tall, is an auto sampler. And this is the auto sampler of the instrument. It is an AOC 6000 auto sampler, and it is meant to do headspace and liquid injection both. So what you're seeing here in front are headspace containers, right? That looks like what we've prepped, but it's not. But headspace containers are there. And then back here in the back, that is a liquid injection. So that is a liquid in there that's going to be injected as a liquid. Remember, headspace is injecting the vapor above the sample, and liquid injection is injecting the actual liquid itself. So that's kind of the difference, and our auto sampler is able to handle both of those sample types with just a switch of a button. That's really all that we've got to do. Here's a closer look of the headspace files that are inside of that sample holder. So there they are, all lined up, nice and pretty. And then those samples are going to be grabbed, and those will be taken to a shaking oven. And the shaking oven looks like this. So over to the left are going to be the sample containers that you just saw. And on the right-hand side of this auto sampler is an oven, and this is the oven piece. So there is a door up here at the top that will slide back and forth. So it will open up, and the sample container slides down into the oven, and the door closes back. And then that sample container, the headspace vial, is going to be heated for a certain amount of time. And then injection is going to take place once those vapors are getting released. The auto sampler is operated by something called a Game Boy, and that's what you're seeing here in the picture to the right-hand side that I've just circled. So if you come back from the days like I do where Game Boys were a thing, then it kind of looks like a Game Boy in a way, and that was the old school way of playing video games. So that is great. I love that, and not a problem. Very easy to use, very simplistic. Not a lot of thought really has to go into using the Game Boy. It is just really a way that we control the auto sampler separately and give it some of the settings that we need in order to make this operational. So that again is going to be in a completely different video that you're not seeing right now. So here is the picture that is kind of all together now. Let's go! Charge! There's our GC, and there's our FID, and there's our auto sampler on the top. I would say that in total, all of this costed around $60,000 to $70,000, and that was with an academic discount. So Shimatsu's always been really good to us, and they have discounted their instrumentation in order for us to get it into our academic labs. So that's kind of the system that we're going to be using. Not very many community colleges in the state have this capability, and you're one of the few that get to actually use it and see it in action. This instrument is going to come around again later on in the program in a completely different class. But if you're taking forensics first, then this is great because you're seeing me use it, and then you'll use it a little bit later. Here in this picture is the top of the hydrogen generator. So basically what I mean by that that is if I go back to this hydrogen generator, up here on the top of the lid, you can kind of see a hinge right there. That lid opens up, and when you open that up, there is a jug on the inside, and that jug is right here. So I actually loosen that lid, and I pour water into the hydrogen generator, so that way we can make sure that it's full, because it needs water to make hydrogen gas. So with that said, we need to make sure that the hydrogen generator is full, that it's ready to go, and everything is kind of squared away. As far as the auto sampler goes, all right, so if I go back up to the auto sampler, here's the bigger picture of the auto sampler. Right up in here is going to be the needle or the injection, and that's where it begins to grab things. All right, so let's look at a closer look or a closer view of what that kind of area looks like. So if I zoom in, right here is the magnet that I mentioned with the headspace containers. This operates off of a magnet grabbing system, so that is magnetized, and it will sit down on top of the auto sampler vial, and it will just basically stick like magnets do, and then it will raise it up, and it will take it over to the oven, and it will drop it down into the oven using that type of mechanism. There is no grabber arm that grabs things. There's no shifter. There's no mover. It is all relying on magnets and not what we call a grabber arm at all. All right. And again, you'll see that in the next video when we start talking about software and getting the samples into the software and getting the machine operational. Finally, what you're seeing in this picture is the top of the GC. So again, if I go back to the main picture, and this is what that looks like, I've just taken a picture of this area right here. That is what you're seeing in this image. And the reason I do that is because this is where injection is going to take place. And this is also where the FID detector exhaust system is at. So in this picture, it's kind of fuzzy, but right here, I call it the chimney stack. This is the exhaust of the FID. So there's a lot of heat that escapes through the top of that detector, because keep in mind there is a flame on the inside, which is what the F stands for, flame ionization detector. So there is a flame on the inside of that, and that flame is generating some heat and some condensation, and we need an exhaust so that stuff does not build up and become awful and crazy where we can't really keep a hold of it anymore. All right. So with that said, I'm going to go back to this, and we're going to talk about this video, and this will be the last one that you'll see. I'm just going to power this system on. That's all that I'm going to do. And in doing that, you're going to kind of see the startup of each of the pieces of the instrument at this point, not software, and nothing other than just where are the power buttons. So that's what we're going to put a focus on in this video. And that will be it. So after this video is over, I think you'll have enough to answer some of those Canvas questions. I've gabbed for 1 hour and 45 minutes, and that's perfectly okay, because that's work that you did not have to do, manual work. I did it all, and it probably would have taken you a little bit longer to do it versus me, because I shortcutted many of the sample prep steps for you. You didn't actually get to see all of it in person. I showed you a few, but not everything. All right, so in the next video, when you come back, we'll talk about instrumentation, but please watch this last one. I'm turning the machines on for you, so that way they can be ready by the time you get to that second video.
All right, guys, it's time to load samples up on the instrument, and this is our GC 2014 from Shimatsu. It is a headspace system. You can see the headspace system up here on top. The GC itself is here, and then to the left of that, that's where our hydrogen generator is. So to turn the machine on, which is the first thing that we're going to go through in this video, there was a power button here on the right-hand side. So I'm going to flip that, and that cuts the power on to the GC system. It's going to start up. Then there's another power button over here on the left-hand side of the hydrogen generator. We like to make our own hydrogen as needed, so that way we do not have hydrogen tanks that are just in our lab space that can go boom. With that said, we do have a backup hydrogen tank just in case we do need it at some point in time. There's also another power switch, and the other power switch is up here to operate what we call the Game Boy, which in this image it's almost out of sight. The Game Boy is up here at the very top. It's a handheld device that controls the auto sampler and then the auto sampler itself. So that power switch is going to be back here to the back, and I'm going to flip that on as well. So 3 power switches that operate this instrument: the auto sampler and the Game Boy piece, the GC, which is right here, and then the hydrogen generator, which is here to the left. Now, with each one of these, I'm going to zoom in a little bit closer so that way you can see what each one of these things will be doing as we begin to analyze our samples and to process data off of this thing. One of the first things that I'm going to show you in the next video is the hydrogen generator that's here to the left. We need water in that generator, and there is an opening up here at the very top of that instrument that we will have access to a well or a container, and that is where we put deionized water in. So again, I'll zoom in a little bit closer. I'll kind of show you where we would do that. On the front of the hydrogen generator, you see a water level. My water level is like right here currently. Now that we know water is there, we don't really necessarily need to refill it, but that is something that we can do sooner or later. Up here at the very top, you're seeing the auto sampler that's getting ready to kind of do its job and move around. It's just kind of figuring out where the home is at, so it's somewhat trying to reset itself if it can, and it's just double checking everything to make sure that it is ready to go. So that is our auto sampler, very, very tall, much taller than I am, and this thing is just going to go through its motions, making sure that the startup is going to be a breeze and that it's ready to analyze our samples fully. We'll kind of look at the auto sampler when it actually starts running samples a little bit closer, but for now, this machine is now started up.
All right, guys, that's it. So good luck on the Canvas assignment for Part A. We've done with the sample prep. And in the next video with another additional assignment that will come along with it, that will question you on software, pieces and parts, how we ordered stuff, how we named it, what steps did we take in the software, and so forth. So good luck. Let me know if you got any questions, and welcome to the world of blood alcohol concentration. So again, forensic chemists have to do this pretty much every day. It's one of the common tests that we do in a laboratory setting as far as the forensic fields go. So blood alcohol, right here, we could be a crime lab that do blood alcohol concentration if we want it. We got everything that's needed. Hello, can we make some extra money on the side? Put it in a Chemtech club so we can go on trips.